So we're going to actually wrap up the unit with triangles, sort of all things triangles. And remember, a triangle is just a type of polygon, except it's got three sides. Okay? And how do we label triangles? Well, much the same way we did quadrilaterals when we looked at them in previous lessons. Sorry, I forgot to get them on my little thing here. There we go. Should be clear enough. Obviously, a triangle has three corners or vertices, and we label each of them with a capital letter. So in this one, it's T, W, and D. And normally how we label sides in a triangle is we label it with a lowercase letter opposite its capital letter. So we're going to name this capital B at this corner or vertex, then the opposite side will be little d. We're going to name this one capital T at the vertex, and the opposite side is going to be little t. And then same with capital W and little w. So capital means an angle or a corner or a vertex. Lowercase means a side. Types of triangles. Well, depends on what we're going to look at. If we look at their sides and their angles, there's three basic types of triangles. One's called the scalene, okay, in which all the sides are different lengths. Okay. And by the way, in a triangle, you can always find the largest angles, the second largest angle and the smallest angle, by looking at their opposite sides. So whatever, if you draw a triangle, whatever angle is the largest, in this case it's A, that means the side opposite that angle must be the longest side. And then similarly, if you look at this one, C is the smallest angle out of the three. So that must mean that its side opposite is the smallest side of the triangle. But scaling has all sides different, therefore all the angles will be different measures. In an isosceles triangle, two sides are the same. One side is different. So in this one, here's an example of an isosceles where little b and little c are the same. But little a clearly is longer than those other two, so it's different. And if it's got two sides the same, the angles opposite the sides, so these two angles here, capital B and capital C, they'll be the same. And then this one will be a different measure. And then finally, if all the sides and all the angles are the same, we call that an equilateral triangle. So all these sides, I would put a single notch to represent they're the same length. And all these angles, I put a single notch to say that they're all the same measure. Now, another type of triangle that we look at quite a bit is a right triangle. A right triangle can be scalene or isosceles. It's like a right triangle could have all three different side lengths, meaning it's scalene, or the two legs could be the same length. which would make it isosceles. Can never be equilateral. Okay? So how do we tell a right triangle? Well, one of the angles in the triangle is 90-degree angle. And the side opposite that 90-degree angle, which is going to be the longest side, we've seen that word before, hypotenuse. Okay, so judging by scaling, isosceles, or equilateral, how would you classify these? We're not going to classify them as right. What would the first one be? Scaling. Because all the sides are different. Yeah. Which means all the angles are different. How about B? Isosceles. Because two of the sides are the same. Therefore, two of the angles will be the same.
Isn't the second one, the third one also isosceles?
Yes. Because in an isosceles triangle, two of the sides are the same, as are two of the angles.
Mm-hmm.
So that would make these two the same. The fourth one, D, is equilateral. All the sides are the same, which means all the angles are going to be the same. This one. Why?
Because there's two sides and two angles.
What's this angle?
Um,
And we know that it's 70 because all three of these add up to 180, right? So yes, you're right. So it's actually the same as this one. Yeah, good job. So it's isosceles. And this last one, not right. We're not classifying it as right. Look at the angles on the sides. So this is 65. This is 90. This must be
So it's part of
25.
scaling, say that word?
Scaling. All the angles are different, which means all the sides are different. So it's scaling. It's a right triangle, but it's also scaling. Knowing the properties of these, let's do the next couple of examples. So we have to find the measures of angle A, angle B, and little c. Well, little c might be the easiest one. What's little c? 4. Because it's opposite capital C. Angle B might be the next easiest one. It's 63 degrees because it's the same measure as the one on the right side. Why? Because their opposite sides are the same length. Okay? And how would we find angle A? Yeah, add these together, subtract it from 180. So 180 minus 63 and 63, or 2 times 63, will give us, what, 54? 54 degrees. Okay. Okay, the next one, we're asked to find angle B, little b, which means side B, and little c, which means side C. So angle B is probably the easiest thing to find first. Wouldn't we just add the two angles we know and subtract it from 180? Add 86 and 47, take it away from 180. And I get 47 degrees. That tells me the type of triangle it is. What would it be? Isosceles, because two of the angles are the same, which means they're two opposite sides of the same. So what's little b? And what's little c? Little b is 7. What's little c? Also 7. Because it's isosceles. Couple more examples. What's the measure of each angle in an equilateral triangle? Yeah, all the angles are the same, right? So what's the sum of all three angles? 180. And if they're all the same, just divide by 3. So yes, 180 divided by 3 is going to get me 60 degrees. And is an equilateral triangle regular or irregular? You got to remember what those mean again. Regular means any regular polygon means all sides are equal. So is an equilateral triangle regular or irregular? Regular. What about an isosceles? Irregular, because not all three sides are the same. We've actually already been doing this with a couple of questions, but we can find a missing angle in any triangle if we know the other two angles by subtracting the sum of them from 180. So if I wanted to find angle A in this one, I would add the two angles I know, 37 plus 46, subtract them away from 180, and I get what, 97? Okay. Yeah, 97. Okay, so those are the types of questions we can answer involving scaling, isosceles, and equilateral, as well as the sum of the angles are 180 degrees. What else can we do with triangles? Well, we can find missing sides using a couple of different types of math. Okay? And the first type is something you learned quite a while ago. If you know two sides in a right triangle, you can find the third side by using the formula a squared plus b squared equals c squared, or the Pythagorean theorem, where a and b represent the legs or sides of a right angle. Those are the two sides that make up the right angle in a right triangle. And the longest side is the hypotenuse. So in this example, how would I find the missing side called h? Well, I use the formula a squared plus b squared equals c squared. What could I substitute for a? 9, and then 6 for b, and then instead of c, right? Look at the diagram. What's c called? H. So 9 squared plus 6 squared, well, that's 81 plus 36, which gives me 117. Therefore, H is going to be equal to the square root of 117. And usually, because we're doing problem solving, we would use our calculator and estimate it. That'd be 10.7, 10.8. It's close to 121. I'd say 10.8. I better use the calculator just to make sure I'm right. (117) square root 10.8, yes. Okay. So we use Pythagoras to find the missing side in a triangle, but what if angles are missing? That's when we need another type of math. That's when we need trig. And trig is something we first learned in grade 10. I'll talk about it next class. Okay, I'm just going to stop there for the time being. And then we're going to do a little bit of trig beyond that you guys actually did. But